Hello everyone! Welcome back to our math class, Halina't Matuto. So once again, I'm Mrs. Maria Ellen M. Lucito, your math teacher. After going through this session, you will illustrate a circle and the terms related to it, like radius, center, arc, chord, central angle, and inscribed angle. But before that, let us play this rebus puzzle. I will give you 20 seconds for you to solve this puzzle. Let us check your answer. Circus minus US plus leaf minus EF is equal to circle. Very good. And that is circle, our topic for this session. Welcome to Quarter 3, Week 7. Now, look at the picture. How many circles do you see? I'll give you 10 seconds for you to count the number of circles. Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 circles. The circle is the most common shapes in our daily life, and indeed, the universe. Planets, the movement of the planets. Natural cycles, natural shapes. There are circles, absolutely everywhere. The circle is one of the most complex shapes, and indeed, the most difficult for man to create. Yet, nature manages to do it perfectly. The centers of the flowers, eyes, and many more things are circular, and we see them in our everyday life. We can say that those are natural or God-made. However, circles are abundant in our daily life in regards to man-made objects too. Circles can be found in modern architecture, in the house, and out on the street. Without circles, we wouldn't have cars. Cars only work because of the circular motion that is produced to make the circular wheels go round. Without circles, the motion wouldn't be created, and the wheels simply wouldn't be moved properly or make the car move. If you're into sports, then a sudden lack of circles would completely ruin your sporting activities. In many sports, balls are necessary, like football, tennis, ping pong, golf, and so many more. Without circles, there would be no spears, and these sports simply wouldn't be possible for anybody to play. The use of circles in transportation. General locomotion would be ruined too. It is not just cars that use circle as a method of movement. Nearly all vehicles use circles, including cars, bikes, trains, and more. Public and private transport would near enough grind to a halt. Even helicopters couldn't fly, as the blades that lift it into the air spin around in a circle. From transport, cooking, circles are prominent and abundant everywhere. Now let us have terms related to a circle. Circle is a set of all points equidistant from a given point called the center of the circle, and that is the symbol. You're going to draw a small circle and put a dot on its center. Chord is a segment whose endpoints are on the circle, while diameter is the distance across the circle through its center, also known as the longest chord. Again, diameter is a segment that passes through the center of the circle, and it is the longest chord. Diameter is a chord, but chord is not a diameter. Radius. The radius is the distance from the center to a point on a circle. It is half of diameter. Next, given the diameter, find the radius. For the first circle, the diameter is 24, the radius is 16, the radius is 4.5, while the last circle, the diameter is 12. Using circle P, determine whether each statement is true or a false. Number 1. RT is diameter. Okay, correct. That is false because RT is a chord. Number 2. PS is a radius. Okay, you're great. That is a true statement. Number 3. QT is a chord. Okay, very good. That is true. Now, let us have the tangent line. A tangent line is a line that intersects the circle at exactly one point. And that point of intersection is called point of tangency. And it forms 90-degree angle with one of the radius. A second line is a line that intersects the circle at 2 points. A secant contains the chord of a circle. This time, name the terms that best describes the notation. The red line. What is the term related to the red line? Okay, that is secant. How about the purple one? Very good. That is radius. How about the blue one? Correct. That is diameter that passes through the center of the circle. How about the green one? Correct. That is chord. A chord contains 2 points of the circle. The endpoints are the points on the circle. The black one. Correct. That is tangent. A tangent line intersects the circle at exactly one point. That point is the point of tangency. Okay, so now let's have a review. Identify the following parts of the circle. So I'll give you 10 seconds to answer the following. Number 1, segment DC, that is chord. Number 2, segment AB, that is radius. Number 3, segment AC, that is diameter. Very good. Number 4, okay, correct, tangent. Number 5, that is secant. Congratulations! So now let us continue. Let us have the central angles. It is an angle whose vertex is at the center of the circle. As you can see in the example, angle APB is a central angle and it consists of radius. Next is the inscribed angle. It is an angle formed by 2 chords. So as you can see, angle ABC is an inscribed angle wherein the vertex is on the circle. The chords are segment AB and segment BC, and the vertex is B. There are 3 types of arcs. First is the minor arc, wherein it is less than 180 degrees. To name the minor arc, we use two letters like arc AB. Next is the major arc. Major arc is greater than 180 degrees. In the figure, arc ACB is the major arc. We use three letters to name the major arc. The third type of an arc is a semicircle. It is an arc that equals to 180 degrees. To name, use three letters like arc EDF. This time, identify the parts, the minor arcs, the major arcs, and the semicircles. You may write arcs as many as you can. These are the things to know and remember always. Always remember that a circle has 360 degrees, a semicircle has 180 degrees. Vertical angles are congruent, while linear pairs are supplementary. Remember that the intercepted arc is equal to the measure of the central angle. Let us have this example. As what I have said, the measure of the central angle is always equal to the measure of its intercepted arc. X is equal to n, wherein n is the intercepted arc. The central angle is x, while the intercepted arc is n. So the measure of angle ABC is equal to the measure of arc AC. If angle ABC is 80 degrees, then arc AC is also 80 degrees. In the diagram, if the measure of angle XYZ is 68 degrees, find the measure of a minor arc and the major arc. We know for a fact that the measure of the central angle is the same as the measure of the intercepted arc. And circle is equal to 360 degrees. 360 degrees minus 68 degrees is equal to 292 degrees. Having those concepts, you try the following. Kayo naman, find the measure of each arc, wherein segment EB is diameter. As you can see, angle AQB is a central angle. So, AB is 96 degrees. ACB is 264 degrees. And because 360 minus 96 is 264. And arc AE is 84 degrees. And that is arc addition postulate. Using arc addition postulate, you try this.
Get ready to the countdown.
As the saying goes, if you want to be good in mathematics, then you do math. On your paper, given circle B, find the measure of each arc. You may pause and play this video. So I'll give you 10 minutes to do this activity. Okay, number 4 is 90 degrees. Number 5, 29 degrees. Number 6, 180 degrees. Number 7, 241 degrees. Number 8, 270 degrees. Number 9, 270 degrees. Number 10, 180 degrees. 11, 90 degrees. 12, 119 degrees. 13, 331 degrees. 14, 209 degrees. And 15, 270 degrees. Congratulations! At para sa gawain, panoorin at pag-aralan ang video. Sagutan ang assimilation at reflection phase. At ang pagubilin, saan gagawa kayo ng math foldables katulad ng nasa larawan. Ito ang pamantayan sa paggawa. See you again in our next video. Thank you and stay blessed. Bye!